I'll give you physics exam number 5 to allow you to measure your understanding in vector addition and friction. In this tutorial, I'll teach you everything you need to know about friction. It's going to help you understand why a body at rest, why body 1 at rest and body 2, when it experiences some applied force, then its friction, static friction changes from 0 Newton to 1 Newton to 2 Newton, all the way Fs max. And if you apply a tiny more, 0.000001, if you like, then it changes from Newton's first law to Newton's second law. Everything you need to know about friction. So let's go over. Let's start our conversation with a box. So a box is sitting, and this is 8 kilogram. Let's find the weight. The weight is, of course, ma, Newton's second law. M is 8 kilogram, and A is 9.8 meter per second square. I didn't put negative because there is an arrow downward. So Fg is 78.4 kilogram meter per second square. So Fg is 78.4 Newton. The normal force is equal in magnitude, opposite in direction, because there is no net force at the y direction. So 78.4 Newton. Okay. So next thing we're going to do, we're going to try to understand the friction. So for the friction, we're going to write force of friction. Force of friction, we're going to divide in Fs and Fk. Fs, let's use red for Fs. Fs mean and Fs max. Fk mean Fk max. Fs mean, if you draw a graph, and we will draw a graph, the x-axis is F applied, Ff, and this is Ff. Okay? Alright. So I'm going to change the Ff. I'm going to put Ff over here and force body diagram over here. Okay? So F, this is your x-axis. Ff, this is your y-axis. X-axis, y-axis. Alright. So the friction graph look like this. This is friction graph. So it has a black region, it has a red region, and it has a blue region. We're going to call location 1 location 2 and location 3. Okay, so Fs mean falls under location 1 right here. So Fs mean is mu s Fn. In fact, Fs mean is 0. Why is 0? When the object at rest, its friction is 0 by definition. Okay. Fs max is mu s Fn. Mu s is, I gave you, mu s is 0.3 and mu k is 0.2. Mu s is always bigger than mu k, because Fs is always bigger than Fk. Alright, I'm going to draw this graph again over here to write the few things. This is Newton's first law. This is Newton's second law. This is transition. This vertical line is transition from Newton's first law and second law. This peak is constant velocity. Constant velocity. So this location 2 is constant velocity. Location 1, object is rest. Location 3, acceleration is greater than 0 or acceleration is less than 0. Doesn't matter. The object is accelerating. Okay, so this is 0.3. Fn is 78.4. So this is 23.52. And this is also 15.68. Alright. So this 15.68 is, I'm going to draw it over here again, the same thing again and again so you understand it. Make it blue. I'm going to call it Fk, and this is constant. As you see that this doesn't change, so 15.68 Newton, of course. And this one changes from 0 here to 23.52 here, so this is Fs. Fs can be anything between 0 to 23.52 for this problem. If the mass is 8 kilogram. If you change the mass, that would be different. If you change the mass from 8 to 10, then maximum, if you, for example, change the mass at 10 kilogram, and mu s is 0.4, mu k is 0.3, then Fs would be 39.2. Okay, that Fs would be 39.2. So if you increase the mass and you changes the friction, the Fs changing. But one thing you understand that there is a max, there is a limit to the Fs. So this, for this scenario, the Fs would be, Fs mean would be 0, Fs max would be 39.2 for this scenario. For this scenario, Fs mean is 0, Fs max is 23.52. Okay, so far so good. Now, on the other hand, you see that the kinetic friction, even if you apply more force, you apply 23.59, then kinetic friction is 15.68. If you apply 23,000, it's still same. 23 million is still same. Okay? Alright. So, any forces you apply more than 23.52, this is going to be constant. Any forces you apply less than 23.52, this object is at rest. If you apply 23.52, this object is at constant motion. With this understanding now, let's complete the table. Let's say 0, let's say 10, let's say 23.5, 23.52 and 24. We gonna be these three, you notice, is this. This one you notice is this, location 2. So I'm going to put 1, 2, 3, 4, 5. 5 scenario, only scenario 4 is location 2, at location 2. Scenario 5 at location 3. And scenario 1, 2, 3 is at location 1. Get it? I'm trying to help you understand as many different ways as possible so that you do not fail the test tomorrow. Of course, I'm going to challenge you so that you allow yourself to measure your understanding from various different angles. Is 0 less than Fs? which is what? Fs max, which is, as you see, 23.52. Yes, 0 is less than that, so it automatically become force of friction. It's 10 less than 23.52, which is Fs. Yes, so it's immediately become force of friction. It's 23.5 less than 23.52. Yes. How much less doesn't really matter, it's less. So 23.5 is 23.52 less than 23.52. Well, no, you have to put an equal sign. So that means these two values are the same. That means this is constant velocity. That means this is location 2, where the applied force and force of friction are the same. So there is, as if there is no friction, okay? Because both components are same. If both components are same, then there is, as if there is no friction. This one cancel this one. What happened then? Object start moving with constant velocity. I did not show these two because they cancel each other. Alright, so 23.52 is 24 less than 23.52. Well, no, 24 is more than that. If this is the case, then object accelerate. Why is that? Because 24 is more than 23.52. So now the another question is, if applied force is 23.52, the force of friction is no longer 24, then no longer 23.52. Why is that? Because it's no longer static friction. Maximum static friction is 23.52. If you apply more than that, then it's no longer static friction, it's kinetic friction. And what is the kinetic friction? Look at over here, 15.68. So 15.68. So this is then 15.68. Okay. All right. So now we will do a few other things on this graph. This point is 23.52, comma 23.52. This is FA and this is FF. And this point is 23.52, this point is 15.68, comma 23.52. 16.68, comma 23.52. This point is here, and this point is here. All right. Okay. All right. So, and this point is here. Okay. So this is FF. So this is 15 point. So you put X first, so this is 23.52, comma 15.68. 15.68. So this is 23.52. All right. So this point made up this two value, and this point made up this two value. Newton fast law at rest, 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 Newton fast law in motion. If it is 23.52 or 23.5200000001, a little bit more, then it becomes Newton's second law, because then object is accelerating. Object is accelerating. Okay, good. Now let's finish this. This is 78.4. This is 78.4. 78.4. 78.4. 78.4. 78.4. 78.4. 78.4. 78.4. 78.4. FBD only two vectors, four vectors equal in magnitude opposite in direction, four vectors equal in magnitude opposite in direction, four vectors equal in magnitude opposite in direction, four vector one is bigger than vector, this vector is bigger than this vector. Fs, yes, this is object at rest because it's right here. This is object at rest because this is right here. Object at rest because this is right here. Object object at rest, okay. And then this one object, okay, that's it. This is doesn't apply. Doesn't apply, doesn't apply, doesn't apply. Okay. Object, this one object, okay, so let's go to net force. Net force is 0 because of course this one minus this one is 0. Net force is 0 because this one minus this one is 0. Net force is 0 because applied force minus force of friction is equal to 0. This is 0 because applied force minus force of friction is 0. This is 8.32 because applied force is 24 and force of friction is 15.62. Acceleration. Acceleration is 0 because 0 over 8 is 0. 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 8.38 over 8. So how you going to find this acceleration? Maybe for tomorrow is very important for you to know. So I'm going to draw a free body diagram. This one, make it look bigger over here. This is FA, which is 24. Of course, Newton. This is FF, of course, 15.68. F equal to MA. You are not counting the vertical vectors because they cancel each other. You are only counting the horizontal vectors. You counting all vectors at the x direction, put sigma. This is positive because this is to the east. This is negative, this is to the west. And 24 minus 15.68 is equal to NA. A is 8.32 over N. So 8.32 over 8, 1.04. So acceleration is 1.04. Forces 2, 4, 4, 4, 4. You can count them. Law, Newton first law because it's right here. Newton first law because it's right here. Newton first law because it's right here. Newton first law because it's at the peak, right here, location 2. Newton's second law because it's right here. Motion, rest, because it's right here. Rest, right here. Rest, right here. Constant velocity because it's at the peak. Increasing velocity because right here. We finish the table. Now it's time to give you a greater understanding by solving problems with friction. So let's start from here. I think we can start from there and come this way. Force can be defined by pull and push. We are talking about force of friction today. It's a type of force. we can divide force of friction. Today we can divide it in, I'm gonna put it over here in the middle. So force, we are talking about force of friction. Newton first law, transition, and Newton second law. Transition, let's call it rate. Newton's second law, let's call it okay. Let's draw the graph. Newton first law, transition, Newton's second law, Newton first law, transition, vertical line, Newton's second law, horizontal line, Newton first law, diagonal line, including the peak, transition, the vertical line including the peak, Newton's second law, the horizontal line. Remind you, F applied, F. Let's give you some problem. I'm going to give you 3 problem, this, 3 problem with this, 2 problem probably with this. Okay, so let's start with the problem. This one, first understand that this one has to deal with mu s or mu k. Of course, mu k, because I'm gonna give you all problem on location 2. That's it. Location 1. Location 2. Location 1 we're gonna go there in a second, but location 2. All this problem come from location 2. Location 2 is Newton first law. Okay, so mu k, because object in constant motion. Alright, mu s, no, because object in constant motion. I'm gonna use F pole, F. Let's make it F keep and F push. Let's give you 3 scenario. Scenario 1, I'm going to give you a box which is 80 kilogram. Not box. It's we are approaching to Christmas. That means lots of snow coming. Moving forward, you're gonna see lots of snow. When you see snow, what do you do? You walk on the snow. If you do walk on the snow, then the snow has a lot less friction, right? Almost no friction. If you walk with constant velocity, then friction is even less, almost 0, which is 0.05. Good. This one I'm going to give you, this is I give you mass, this is I give you weight. Be careful, they are not the same thing. And this is I'm going to give you weight. You don't have to make it weight, you don't have to make it weight, you have to make it weight. So this one weight, you have to multiply with 10. So today we are using 10 as acceleration due to gravity. 80 times 10, 800 Newton. This is weight. This is normal force. 800 Newton. Notice I'm not gonna making this one. I'm not gonna multiplying this one with 10. This is already Newton. Just write 60 Newton. This is already Newton. Like just write 200 Newton, that would be it. The weight is 200 Newton, that would be, that's more than enough. Transition, I'm going to make transition right here. Okay, let's solve this problem and then we're going to do transition. Okay, So now I'm going to give you mu k since you are walking on the snow. You are walking on the snow with constant velocity. How do you know? Because those arrows are the same. Okay. I want to know you're pushing force. Oh, you push the snow by using what? Your feet. This is snow. Your feet pushing the snow. I want you to find pushing force. Your feet, both feet push the snow. How much? So that you keep the constant velocity. Mu k Fn. Mu k is of course 0.05. Mu k does not have any unit. And Fn is 800 Newton. So this is 40 Newton. Your feet exert 40 Newton so that you can have constant velocity as you walk on the snow. What did I test you? I test your understanding what part of the graph does it fall, location 2. You have to understand that you have to multiply it by 10 so that you can get the weight, and then you can get the same normal force, and then you use it. The second one, what happened is, instead of snow, this has to do with the snow. Now change the surface. Now I'm going to use the dry asphalt. The dry asphalt. Now what would be the force needed? What is the applied force needed so you can keep the weight at constant velocity as it moves on the dry asphalt? Of course mu k, because this is again location 2, because Newton's first law, constant motion. Fn. So Fk, mu k, dry asphalt is 0.67 times 60, and that will give you 40 Newton. Scenario 3. Scenario 3, I ask you, hey, you have a 200 Newton object. Your applied force is 10 Newton. I want you to find out mu k. Right? Very simple. I want you to find out mu k. You know that mu k is Ff over Fn. How you know that? Well, in the beginning I give you Ff is mu Fn. In this case, you are not 100% sure whether it's mu s or mu k, but you do. This is location 2 of the graph, and location 2 is constant motion. Put mu k. Do the algebra, then you're gonna get this. Ff is of course, what do you get? Ff is, I gave you Ff. What is Ff? Ff must be, I didn't give you Ff, but Ff must be equal in magnitude, opposite in direction. So Ff must be 10. Why? This guy is constant velocity. I told you this is over here. Over here means constant velocity, meaning there is no net force, meaning this one cancel with another one which is equal in magnitude. What does that mean? That means this one has to be same in magnitude with this one. If you know Fa, means you know Fn. Good. So Ff is Fa. Ff is Fa. Okay. So 10 over 200. All right. Okay. So we're done with this. Now we're going to do transition. transition, we are here at red region, this region. This is transition. This is transition. I give you transition, including transition means it's peak, including the peak. That's what transition means. The vertical line, transition. 3 problem. Okay. Problem 1, I gave you some mass. Problem 2, problem 1, I gave you 300 Newton, so it's not mass. I give you the weight. This is 300 kilogram. I give you the mass. This is 100 Newton. I give you the weight. This one is steel. This one is steel on steel. This one is steel on steel. And this one is wood on wood. Now let's figure out whether this is mu k or mu s. You have 50-50 chances. Mu k or mu s. Well, it's very easy. This problem is talking about what is the minimum force you need to make the object moving. What is the minimum force? We have 2 things. Location 1, anything, location 1, location 2, okay, so location 1 is 0, this is location 2 23.52, and this is 19, this is what is it, 78.4 times 0.2, this is 15.68, alright. What is the minimum force you need to make the object moving? The object is rest, object is started with rest, object is at rest. To make it moving, 0 Newton, no. 1 Newton, no. 20 Newton, no. 23.5 Newton, no. 23.52. That's how much. Okay, alright. If it is 8 kilogram. This time it is not 8 kilogram. It is way more. It is 30 kilogram. Okay, so how are you going to find out? How did he find out? He found out 8 kilogram, you wrote mu s Fn 0.3, 8 times 10. 78.4 times 0.3 is 23.52. How are you going to find this out? Very simple. You're going to use Fs max is equal to mu s Fn. Fs is, mu s is, in this case, this is steel on this steel, so it's 0.74. So times, what is it? Fn is 300. So 222 Newton. And this is mu s Fn. So this is, you have to make it weight. This is not weight. So 3000 Newton. So this must be 3000 normal force. Mu s. What is mu s? Mu s is 0.74 times 3000. So it's 2220 Newton. Now wood on wood. Okay. Mu s Fn is equal to Fs max, of course. Mu s is 0.42 and weight is 100. So it's 42 Newton. Now let's do Newton. Second law finally. I gave you an object which is 0.5 kilogram, and I said that object is slowing down. That object must be slowing down. How do you know? Arrow are getting smaller. So what causes the slowdown? Force of friction. How much? I gave you 1.2. Why is slowing down? Because there is no cancelling force. If there is a cancelling force of 1.2 on the other side, then this is not going to be slowing down. This is going to be, now this is constant velocity. Now this is speeding up. Now this is slowing down. This is what I gave you. Okay, if it is slowing down, it's not here because it's rest. If it's slowing down, it's not location 2 because that's constant velocity. If it's slowing down, it's here. Why? Because this is Newton's second law. And slowing down and speeding up is Newton's second law. Okay. What I want to find you? I want to find you mu s or mu k. Of course mu k because object is in motion. Slow down or speeding up, they both are motion. So no mu s. So mu k is ff over fn. Ff is, of course I gave you 1.2. And fn is, of course you're going to find it. Use 10, so 5 Newton. So this must be 5 Newton. So this is 0.24. And there is no unit to the, of course, coefficient of friction. Tomorrow I'll give you probably a vector problem like this. I don't, this is only you need to know about friction. So this is like everything in terms of friction. Okay, so let's say a mailman, this is x and y axis. A mailman walks, let's say 20 meters, 20 miles to the north. And then he makes, this is east, this is north, this is west, and this is south. So he makes some angle at southeast. Southeast. So he turn around. When he turn around, you put an x-axis. Imagine and remove this x-axis over here in your mind. And he moved 60 degrees to the southeast. Southeast means fourth quadrant. Southeast, understand that southeast means fourth quadrant. So 60 degrees southeast means below the x-axis means 60 degrees. This is below the x-axis, alright, clockwise, and this is above the x-axis or counterclockwise. Alright. Okay. So when you find this, the vector of this, make sure you use the trigonometry. This is plus plus, this is plus minus, this is minus minus, this is of course minus, this is minus plus, and this is plus minus. Okay, so the x value would be plus and y value would be minus. Okay, make sure you be careful. Okay, this is important for tomorrow, so you're going to find the resultant. Okay, this would be the resultant. To find this resultant, you have to find both component of this by using trigonometry. How? Let's say this is 60 degree southeast, and this is, let's say, I don't know, this is 20. Seems like 42. I don't know. This is 42. So make sure you do like this. 20 cosine 90, 20 sine 90, and this one is 42 cosine 60, 42 sine 60. Since this is second quadrant, make sure this is the x is minus, y is plus, x is plus, y is minus. So once you have those, this is your x, add them up, and put it in Pythagorean theorem. There you go, you get the answer. Good luck for tomorrow.